Hey guys, I'm gonna go through the 5.8 through 5.9 homework. There's really no open questions or free response questions except for at the end of this one, but most of this is just multiple choice and should be pretty quick. It's just about relating all the functions together. So how do I connect the function with the derivative and with the second derivative? How do I connect all these derivatives and their graphs together? So for one, we have this table. Tables like this are kind of weird, but it has not just like what's happening at x values, but it tells us the values in between them as well. So we have x equals 3. But in between 0 and 3, we can see that f prime is positive and f double prime is positive, and so on and so forth. So the function f is continuous on the interval from 0 to 16, and f is twice differentiable. Okay, except at x equals 3. I kind of paused right there. I'm like, f is twice differentiable. And then I saw this right here. I'm like, what? No, it's not. And then it says except at x equals 3. Okay, yep, we just got to finish reading. So the function f is continuous. F is twice differentiable except at x equals 3, where the derivatives are undefined. Yes. Information about the first and second derivative for f and values of x in the intervals from 0 to 16 is given in the table. At what values of x in the interval does the graph of f have a point of inflection? So whenever I see these words right here, whenever I see these sentences or in the question, f has a point of inflection. This is why it's so important to know your definitions. Like, what is a critical point? What is an inflection point? What is a minimum? What is a maximum? Because it just, if you know your definitions, you know exactly what to look for. So when does f have an inflection point? Well, what is an inflection point? An inflection point is when f double prime changes signs. And where does that occur? It's kind of like when f double prime equals 0 or undefined. And then if it changes signs around that, then there's an inflection point. So again, if you know your definitions and you read this question, you know exactly what you need to look for. I need to look in a table and I need to see where f prime changes signs. Sorry, f double prime. So f double prime, it's positive from 0 to 3. Then it's undefined. Okay, then it's negative. Perfect. I know that x equals 3, there has to be an inflection point. So it looks like it's either going to be B or C right now. And then we have from 3 to 9, it's negative. And then it's 0 for the second derivative, and then it's positive. Okay, then I have my another inflection point. So at x equals 3 and at x equals 9, so that's going to be B. Again, if you know your definitions, you know exactly what to look for. Let f be the function defined given here. On which of the following intervals is the graph of f both decreasing, so f is decreasing, and concave down? Again, if you know your definitions, you know what to look for. F decreasing. What does it mean if f is decreasing? If f is decreasing, then f prime is negative. And then if f is concave up, that means f double prime is positive. I know exactly what I need to find. So we have the graph of f, so I'm going to start by finding f prime. So f prime of x is going to be equal to x squared minus 6x minus 16. And then I'll set this equal to 0. I'll factor it. I'll get x minus 8 and x plus 2. So I got x is equal to 8 and negative 2. Then I'll make a number line. And I'm going to analyze the intervals between these zeros. So negative 2 and 8. Let's test some values in between them. Remember that this is for f prime. So if I plug in values something like 0, I can already tell you right now, this is a cubic function. It's a cubic function with 2 critical points. So that means it's got a what did I just do? 2 critical points. So it's got to be increasing. So the function's got to be increasing, 0, decreasing, 0, and increasing. That's probably what's going to happen. So I'm going to say it's increasing. It's going to be decreasing between -2 and 8, but let's just double check. So if I use 0 in for x right here, that's going to leave me -8 and 2. So yes, f prime is going to be negative. If I use -3 as a value, this is going to be negative, this is going to be negative. So that means f prime will be positive here. If I use values greater than 8, positive and positive, so f prime will be positive. Okay, so I already know that I'm going to be between -2 and 8. All right, so anything right now between -2 and 8 is an option. So it's not going to be A, it could be B, it could be C. It's not going to be D, so it's not going to be A or D. And then now we want to find when f is concave up, so we're going to find the second derivative. So second derivative is going to be 2x minus 6. We're going to set that equal to 0. So then that's going to be at x equals 3. So again, if I make a number line here, we've got at x equals 3. If we use values, in less than 3 here, so something like something like 0, then this is going to be -6. So I can tell you that it's going to be concave down. So f double prime is going to be less than 0. And if you use values something like 4, that's going to be 8 minus 6, so it's going to be positive, so f double prime is going to be greater than 0. So concave up when x is greater than 3, and it's going to be decreasing between -2 and 8, so that's got to be between 3 and 8. Between... One second. So concave down, not concave up. Concave down, so that's going to be between -2 and 3 only. So -2 and 3, so B. All right, looks like we get to use a calculator here. The first derivative of the function h is given by h prime is equal to sine of x plus cosine squared of x plus x. Let's just go ahead and put this into the calculator right now. All right, so we got sine of x. I should probably give this a title. So we're going to call this f of x. So f of x is equal to, and then it was sine of x plus cosine squared of x. So plus cosine squared of x, cosine of x squared. And then plus x. Wowzers, what a crazy function. All right. So the first derivative, so this is the first derivative. This is a derivative, so this is h prime. And the second derivative is given by there, okay. On what open intervals contained in -3 to 2 is the graph both decreasing concave down? So I guess we can throw that in here too. So between -3 less than x is less than 2, I think it was. Now we can also put an f prime here. So f prime of x, and then we can okay, cool. So it keeps it all that right there, but that's just kind of annoying to look at. On what open intervals in this between -3 and 2 is the graph both increasing, concave up? So increasing, h will be increasing. So I'm looking for when f prime is positive and concave down. So it's going to be when f double prime is less than 0. So let's look at intervals where f prime is positive. So f prime is positive. That's going to be between -0.495 and 2. So -0.495 and 2. And then for f double prime, so if I look at this one right here, this is the second derivative, and we said concave down, so that's going to be between -2.4. I mean, I think that's just going to be -2.5. I think that's what they'll probably round it up to. negative 2.499. It looks like what they're rounding it up to. That makes sense. And then we also have between 0.969 and 1.697. So 0.969, what am I writing? I forgot to write the other one. So negative 1.829. Negative 1.829. I'm just reading the values over here because it looks like all the values are represented here. And then we also said 0.969 and 1.697. Okay, so now we just need to find the overlap. And so if we bring them back, I guess we can kind of do that. But we said that it has to be positive. So that's pretty much going to get rid of everything on the left side. And then, so I think it's going to be between here and here. I think, yeah. So in between there, it's where the second derivative is below the x-axis, and in that interval, the first derivative is above the x-axis. So I think that meets our definitions right there. So just keeping that in mind, 0. Okay, and 1 point. So the answer is A. All right. All right, so we got 4. These ones are kind of fun. So the function f is differentiable and increasing on the interval from 0 to 6. So keep this in mind. So f is differentiable and increasing. So f is increasing on this interval. This means, so if f is increasing, that means that f prime is positive. I don't know if I need that. The graph of f has exactly 2 points of inflection. So f has 2 points of inflection, so that means that if there's 2 points of inflections, it's got to change concavity twice. So change concavity twice. Keep that in mind. All right, which of the following could be the graph of f prime? So if f is decreasing, f prime has to always be positive on the interval. So it can't be B, because here we have f prime is negative. Okay, so that gets rid of that right there. All right, and then we also need to change concavity twice. So what am I going to look for here? So here I see that we're concave down. You can see that because you can see the slope is starting to decrease, but then in some point here it starts to increase right here, and then it starts to decrease right there. So I guess that could be an answer. It has exactly 2 points of inflection. Concave down, concave up, concave down. And f is oh, wait a minute. F is differentiable and increasing. Sorry, I'm getting mixed up with my graphs already. F is increasing, so so this is I was thinking that this could be F, but we're talking about F prime. So, but I guess still technically A could be it. So right here, if we go to C, we have this shape right here. Oh, wait a minute. Okay. Yeah, no, I'm getting my graphs mixed up. So, this isn't going to be too helpful for me. This is my problem right here. So this is where my thinking has gone wrong. So, F has exactly 2 points of inflection, so it's going to change concavity. So I was looking for a change in concavity here, and I saw that this graph right here had 2 changes in concavity. But that would be me looking at, this is F prime. F prime has the change in concavity twice. So that actually makes me think that A is not the answer. So I actually need to correct this. So F has exactly 2 points of inflection. Yes, that does mean that it changes concavity, but what does that mean about F prime? So if it has 2 points of inflection, this means that F prime changes directions twice. That's what I need to look for. I have graphs of F prime, not graphs of F, so I shouldn't be looking at these graphs as if they're f. And so that's what we want to keep in mind. So so for A, this is actually incorrect. So this one doesn't change directions at all. This is the graph of f prime, and you can see that f prime is always increasing right here. So this means that f double prime is always positive because the derivative of this graph is always positive. And so this would mean that f has essentially no points of inflection. So I don't think it's going to be A. And then for C, so if we look here, increases, then decreases. So there's a change in direction. So f prime changes directions here. And then it also changes here. So we go from increasing to decreasing to increasing. So this tells me that f double prime is positive. This tells me that f double prime is negative. This tells me that f double prime is positive. And a point of inflection is whenever, like we said earlier, is when it changes signs from positive to negative. F prime positive, f double prime positive, then negative, there's 1. And then negative and positive, there's 2. So I think it's got to be C then. Cool. Like I said, if you're careful with your definitions, like I was not careful with my definitions here, and I was thinking that these were the graphs of f, not f prime. But if you have your definitions and you know what type of graphs you're looking at, makes it very, very easy. But it does take a while to kind of get that down. All right, for 5. The graph of f prime, the derivative of f is shown above. Which of the following could be the graph of f? So again, we've got the graph of f prime. And these graphs are the graphs of f. So what do I need to look for here? So notice, I mean, you can jot down just some things that you already know. So you can see here that f is decreasing right here. So that tells you that f prime has to be negative. And then right here it changes, so then f prime has to be positive. So when I'm looking for a graph of f prime, I'm looking for part of the graph, at least to the left of this x value, it has to be below the x-axis, and then after this value, x value has to be above the x-axis. And so when I look at that, so I think there are a couple right here. So I see like A, F, oh wait, sorry, dang it. I'm getting my graphs mixed up again. I was thinking that this f prime. This is f prime. Okay, so let me correct that. Sorry. This is f prime, and so I see that f prime is above the x-axis right here. So this means that here, in this interval, f is increasing. So f is increasing, and then between here, because f prime is below the x-axis, this means that f is decreasing, and then f is increasing. Okay, so I want a graph where the graph below where it goes increasing, decreasing, increasing. So it's got to be B. So man, it's really easy once you actually get your graphs and definitions right. I think that's all I need right there. Yeah. Perfect. Wait a minute. Looking at C right now. So the graph of this one has to be, oh wait, it's C, sorry. Oh my gosh, I can't get these right. So increasing, decreasing, increasing. This was decreasing, increasing, decreasing. The exact opposite of what I just said right here. So F is increasing, increasing, then it's decreasing here, we're decreasing, and then increasing, increasing. There we go. I started the wrong way, so decreasing. Yeah. So it's got to be C. There we go. All right. For 6, oh my gosh, another graph one. The graph of f double prime. The second derivative of the function f is shown. Which of the following could be the graph of f? All right, I'm going to get this right the first time now. All right, I'm finally going to get it right the first time. So we have the graph of f prime. I'm going to use the same kind of tactic as I did before. So I'm noticing here that the graph of f prime is positive. So if f prime is positive, that means that f is increasing. So f is increasing, then we have decreasing, then f is increasing. So, okay, so it should follow something similar, because we got f prime. I'm going to double check. I already got it wrong, because this is the graph of f double prime. Okay. Redoing this. Like I said, I'm going to get this right the first time, as in the second time. So, f double prime. F double prime is positive, so this tells me that f is concave up. So f is concave up, and then it's negative, so that means it's concave down. And then concave up. All right, so I'm going to look for a graph that has slope that is increasing, then slope that is decreasing, and slope that is increasing. So let's see right here. So I also like to look at the shape of the curve as like a bowl shape or a parabola that's upward facing. So this graph right here starts with a upward facing motion, which tells me that slope is increasing. So slope is increasing, which means the second derivative is positive. And then you can see here, this shape of the curve is concave down because it has a parabola facing downward kind of a shape. And so this tells me that slope is decreasing, so f double prime is negative. So this only has one change, but you can see here that we have two f prime double prime changes signs twice here. So positive, negative, and positive. That's two sign changes. So it can't be A because it only seems to be a 1 point of inflection. So I'm looking for basically 2 points of inflection, and in a way where it's concave up, concave down, concave up. Let's look at B. So you can see here, it kind of has a downward facing parabola shape right here, and then it goes upward facing parabola shape, then downward facing parabola shape, kind of very at the end. So slope is decreasing right here, which would mean that the graph of f must be concave down, but we start with the graph of f being concave up. So I don't think it's going to be B. So let's check C. And for C, we have concave up. You can see that slope, it's a parabola, it's a shape that looks like a parabola as if it's upward facing, then downward facing, then upward facing. So I think we probably have our graph right here. So slope is increasing from here to somewhere around here, then slope begins to decrease, then slope begins to increase right here. So I think it's got to be C. For D, there's like concave up, concave down, concave up, concave down, concave up, concave down. So way too many changes in concavity, which, yeah, not going to be that right there. All right, there you go. I told you I'd get it right at some point. All right, for 7, this is the free response question. We have a graph of f. F is continuous, so the continuous function f is defined on the closed interval from -5 to 5. The graph of f consists of a parabola, and 2 line segments, as shown in the figure. Let g be a function such that g prime is equal to f. So this is the graph of f. I'm also going to put this here is also equal to g prime of x. So f of x and g prime of x are the same. Okay. A, fill in the missing entries in the table below and describe the behavior of f prime and f double prime. Indicate positive, negative, or 0 into these places right here and give your reason. I mean, do I really have to give my reason? We'll see. So between -5 and -3, we see that f prime is positive. So between, well, I mean, all of this is positive. Yeah, you can see that here. Positive, 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 positive. This is the graph of f. It's all above the x-axis. So between -5 and -3 is f prime. What is f prime? So you can see that the graph is increasing, so that means that f prime is positive. Okay? And then between -3 and -1, it's decreasing, so it's got to be negative. Between -1 and 2, we're increasing, so that means that f prime is positive. And then between 2 and 5, decreasing, so that means f prime is negative. All right, and then double prime. So that's the slope of the slope, right? Yeah, and so looking here, you're looking at concavity, essentially. So what is the concavity? So if you have a straight line on the curve of f, then it's neither concave up nor concave down. So slope isn't increasing. The slope is constant right here, which means that slope isn't changing. Slope isn't increasing or decreasing. That means that the second derivative must be 0. So f double prime has to be 0 on the interval. Then you can see here we have, well, it's a parabola, and it's an upward facing parabola. So upward facing parabola from -3 to 2, which means we have a concave up. So that means that the second derivative is positive. And then between 2 and 5, well, again, we have a straight line, so the slope isn't increasing or decreasing. Slope is constant, which means the second derivative is 0. Okay, for B, there is no value x in the interval from -1 to 5 at which f prime is equal to here. Explain why this does not violate the mean value theorem. So there is no value from -1 to 5 for which the instantaneous rate of change equals the average rate of change. So if you take from -1 to 5, if you were to find the slope between these 2 points, you'd find that the slope is 2 over 1, 2, 3, 4, 5, 6. So 1/3. The slope is 1/3 in this interval, the average rate of change. And what we're saying is that, it's going to be -1/3. The average rate of change is -1/3. And they're saying that there is no point in this interval right here where the slope, the instantaneous rate of change, is going to be -1/3. So why is that the case? Well, because it doesn't violate the mean value theorem because there's a corner on the graph right here. So we're not differentiable. So I would just say that because f is not differentiable at x equals, what was it, 2? At x equals 2, which is in this interval right here. So of course it's not going to follow the mean value theorem, or because the conditions aren't even met. So all right, find all values of x in the open interval from -5 to 5 at which the graph of g has a point of inflection. So g, so where g has a point of inflection, that means the definition, again, definitions are just very key here. That means g has a point of inflection, means that, let's think about the information that we have. We have g prime, don't we? So this is the graph of g prime as well. So what does that mean for g prime? So if there's a point of inflection, that means that g prime is going to change directions. So this means that g prime changes directions. So g prime is going to change from increasing to decreasing. So let's go ahead and check the graph right here. So this is the graph of g prime as well. So changes directions right here, changes directions right here, changes directions right here. So I see 3 right there. So find all the values of x in the open interval for which it changes, or where g has a point of inflection. So I'm going to say x equals, what was it? X equals negative, x equals -3. Yeah. So x equals -3, x equals -1, and x equals 2. So x equals -3, x equals 1, and x equals 2. So find all values and explain why. So I'll say this right here, because because G prime changes directions. That's why. I think that's all I really need to say. I don't feel like I need to specify like changes from increasing to decreasing or anything like that. Just changes directions. Yeah. For D, at what value of x does G attain an absolute maximum? So that sounds like the candidates test. So the candidates test is probably what I'm going to use since we're talking about absolute maximum on the closed interval. So remember, the candidates test says we need to identify our candidates. So our candidates are going to be the endpoints. So I'm going to say x and I'm going to say g. So we're going to say -5 and 5. I don't think we have g. That's okay. That's okay. So actually, because then I guess we could say that can I find my critical points? So are there critical points? So G, critical points for G. So critical points for G. I don't think there are any. The only critical points for G are at -5 and 5 because that's when G prime is equal to 0. So the endpoints are the critical points. So what does this mean for us is that the minimums and maximums have to be at the endpoints. And which ones are they going to be? Okay, so you can see here that G prime, this is the graph of G prime is always positive. So I'm going to just, pretty much all this means nothing. So G prime is always positive, which means that G is always increasing. And if G is always increasing from -5 to 5, that makes x equals -5 is the minimum. I'll say G equals -5 has an absolute minimum, and x equals 5 has an absolute maximum. Again, it's just because you have a graph and it's always increasing. Always increasing. So if it's always increasing, the furthest most left point has to be the minimum. The furthest most right point has to be a maximum. There's no critical points in between, which means there's no chance of, and you can see that here, the graph of G prime has no points between -5 and 5 where it's going to be equal to 0. So there you go. That's got to be the answer right there. All right, and that's everything for this homework assignment.